Welcome back to my class in Mathematics of Investment. For today, we will start with a new lesson called Annuity. An annuity is a series of regular payments made at equal intervals. This definition means that an annuity involves more than one payment. It consists of actually a series of regular payments. And these payments are made at regular intervals, and the length of each interval is equal to the length of the other intervals. And some examples of annuities are the following. Number one, the regular deposits to a savings account is an example of annuity. And the home mortgage payment is another example of an annuity. Another example of annuity is the monthly insurance payment and the regular pension payments. Annuities are actually insurance contracts that promise to pay the buyer a fixed amount at a later date or immediately. And there are three major characteristics of annuities. Number one, there are regular payments to be made. The first characteristic is regular payments are made. That is, and these regular payments is just not one payment but a series of payments that are made regularly. The second characteristic of annuity is these regular payments are the same, or the amount of each regular payment is equal. The regular payments are equal in amount, and these regular payments are made regularly. Number three, the regular payments are made at equal intervals. The length of the intervals are equal. And those are the three characteristics of annuities. Number one, payments are regular, or regular payments are made. Number two, the regular payments are equal or the same. And number three, the regular payments are made at equal intervals. That means the length of each the length of the intervals are equal. For today, we will start with the two types of annuities based on timing of payments. If the regular payments are made at the end of each payment period or at the end of each interval, the annuity is called ordinary annuity. Again, ordinary annuity is a type of annuity where the regular payments are made at the end of each interval or at the end of each regular payment. And if the payments are made at the beginning of each interval or at the start of each payment interval, the annuity is called annuity due, D-U-E. Due. Again, annuity due is a type of annuity where the regular payments are made at the beginning or at the start of each payment interval or at the beginning of each interval. And the regular payments are made over a length of time which is definite. And we take these two types of annuities together today because their formulas for calculating the present value and the accumulated value for ordinary and annuity due differ only by a single factor. So I will now write the formulas for calculating the present value and accumulated value for annuity due and ordinary annuity. These are the formula for calculating the accumulated value and present value denoted by P of ordinary annuity and annuity due. For ordinary annuity, the total amount to be received by the payer or the buyer of annuity is calculated by using this formula. Uh, A stands for accumulated value and is equal to R multiplied by quantity 1 plus I to the power n minus 1 all over I, where capital R here is the regular payments to be made at the end of each payment interval. And I here is the interest rate per period. If the interest rate is given as compound interest rate, then I is equal to J, the given compound interest rate, divided by M, the number of interest computations per year. And here is the number of regular payments to be made. If the interest rate I is given as compound interest, then the number of regular payments to be made is equal to N, and N is computed as M multiplied by T, where M is the number of interest computations per year multiplied by T, the number of years. The present value of for ordinary annuities denoted by P and is given by R times quantity 1 minus quantity 1 plus I to the power negative n all over I. For annuity due, the accumulated value A is given by this formula. You can see that the formula for accumulated value for an ordinary annuity and for annuity due differ only by this factor quantity 1 plus I. So if you multiply the right hand side of the formula for accumulated value for ordinary annuity by the factor 1 plus I, you get the formula for accumulated value for annuity due. And this is the formula for calculating the present value of annuity due. Again, you can see that this formula differs from this formula for the present value for ordinary annuity by the factor 1 plus I. If you multiply the right hand side of this formula for calculating the present value for ordinary annuity by the factor 1 plus I, you get the formula for calculating the present value for annuity due, where capital R here is the amount of regular payment to be made at the beginning of each payment interval or interval. And I, small I, is the interest rate per period, and N is the number of regular payments to be made over a given length of time denoted by T in years, We will now take some examples. For our first example, consider the following problem. The treasurer of XYZ company wants to invest 100,000 pesos of their funds in a long-term investment at the end of each year for the next 5 years. The company will earn 7% interest compounded annually. What is the value of the payments at the end of the 5-year period? If the interest on the investment was compounded monthly and the amount invested at the end of each month were 8,000 pesos, what is the value of the investment after 5 years? This problem has actually two parts. In the first part of the problem, the regular payment is 100,000 pesos, and this amount is to be paid at the end of each year for 5 years. And this amount, 100,000 pesos, will earn an interest of 7% compounded annually, and 100,000 pesos to be made at the end of each year for 5 years. So this problem involves ordinary annuity, where the regular payments of 100,000 pesos are made at the end of each year for 5 years. So we write capital R equals 100,000 pesos for the first part of the problem. And T is equal to 5 years. The interest for this investment of 100,000 pesos at the end of each year for 5 years is 7%, denoted by J, compounded annually. 7% interest compounded annually. And 7% in decimal number is 0.07. It's compounded annually, so the interest conversion period is 1, or interest will be computed once a year. And in the first part of the problem, we are asked to find the value of the payments of 100,000 pesos for 5 years at the end of each year, at the end of 5-year period. So the required is the accumulated value, denoted by A, of this ordinary annuity. And this is for the first part of the problem. For the second part of the problem, if the interest on the investment was compounded monthly, that means a 7% interest was compounded monthly instead of annually. So for the second part of the problem, we take J equals 7%, but M is equal to 12, because it says the interest on investment was compounded monthly, but the interest rate remains 7%. Now in the second part of the problem, M is 12. And in the second part of the problem, the amount invested at the end of each month were 8,000 pesos. And so the value of capital R for the second part of the problem is no longer 100,000 pesos, but 8,000 pesos to be made at the end of each month. The required for the second part of the problem, what is the value of the investment after 5 years? And T remains the same for the second part of the problem, which I denoted by D. For both parts of the problem, A and B, the required is the accumulated value of the ordinary annuity, the value of the regular payments at the end of 5-year period. And at ordinary annuity, the formula for calculating the accumulated value is given by the following. At ordinary annuity accumulated value is given by R times quantity 1 plus I to the power n minus 1 divided by I, where n here is the number of regular payments to be made over a period of 5 years. We start with finding the accumulated value of ordinary annuity for letter A, where the regular payments are made at the end of each year for 5 years, and each regular payment is equal to 100,000 pesos. For letter A, the interest rate per period is the interest rate per year, because the given interest rate 7% is compounded annually. But by formula, I is equal to J divided by M. By formula, interest rate per period is J, the compound interest rate per year, divided by the number of interest computations per year. In letter A, the compound interest rate given is 7% or 0.07. Compounded annually, so M is 1. 0.07 divided by 1 is 0.07. And the number of payments for 5 years by formula, N is equal to M multiplied by T. For letter A, the interest rate is compounded annually, M is 1. And the regular payments are made at the end of each year for 5 years. The length of time for the investment is 5 years. 1 multiplied by 5 is 5. Now we substitute R, 100,000 pesos. I is 0.07. N is 5. And we calculate the value of A using our scientific calculator. And you start with 1 plus 0.07 raised to the power 5. You start with 1 plus 0.07, that's 1.07. Raised to the power 5, and you press equal in your calculator. Minus 1 from the answer in your calculator. And then you press equal. And that answer in your calculator, you divide by 0.07. Press equal again. and that is the quotient 5.75073,901, and that answer multiplied by 100,000. And you should get 575,073.90 to 2 decimal places. Hence, the value of the investment that involves 5 payments of 100,000 pesos at the end of each year for 5 years with interest at 7% compounded annually is 575,073.90 pesos. Now we do letter B. We calculate the value of the investment. If the interest rate 7% is compounded monthly and the regular payments made at the end of each month for 5 years are 8,000 pesos. The formula is the same except for letter B, R is 8,000 pesos. And we calculate the value of I, the interest rate per period, by this formula. I is J divided by M, where J is 0.07, 7%. But for letter D, M is 12. The interest rate, 7%, is compounded monthly. You may calculate 0.07 divided by 12 in your calculator, but you take all the decimal numbers, or you can leave it as is 0.07 divided by 12 and substitute that number into this formula for accumulated value for ordinary annuity. But suppose we divide 0.07 divided by 12, you should get 0.0058 and non-terminating 3. So this is a non-terminating decimal number. We leave it as is 0.07 divided by 12. Now we compute N, the number of regular payments to be made over a period of 5 years. And the number of payments to be made over 5 years is computed by this formula. N equals M multiplied by T, where M is 12 for letter B because the payment is to be made at the end of each month. So in 1 year, the number of payments to be made is 12. And the payments are to be made over a period of 5 years. 12 multiplied by 5, and that's equal to 60. Over a period of 5 years, the total number of regular payments to be made, each payment equal to 8,000 pesos, is 60 payments. Computed by this formula, N equals M multiplied by T, where M is equal to 12. 12 payments in 1 year for 5 years. 12 multiplied by 5 equals 60. We substitute 8,000 for R. I equals 0.07 divided by 12. And N is replaced with 60. Again, we compute the value of A, the accumulated value for ordinary annuity for regular payments of 8,000 pesos at the end of each month for 5 years using our calculator. And we start again with 1 plus 0.07 divided by 12 to the power 60. You actually start with 0.07 divided by 12 in your calculator, then you add 1, you press equal, and the answer raised to the power 60. Again, start with 0.07 divide by 12. And you should get 0.0058 and repeated 3. And that answer in your calculator, you add 1 plus 1, press equal. You should get 1.0058 and repeated 3. And that answer in your calculator, you raise to the power 60. Press equal and you should get 1.417625256. It's an ending, non-terminating decimal number. And that answer, from that answer, you subtract 1. Press minus 1. And you should get 0.417625259.1. Again, it's a 59613988. Again, it's a non-terminating decimal number. And that answer in our calculator is the answer in the numerator. And to divide that numerator by this fraction is to multiply the answer in the numerator by the reciprocal of the denominator. So that answer in your calculator, which is actually the answer for the numerator, multiply by 12 and divide by 0.07. The last answer in your calculator should be 0.417625259613988. It's a non-terminating decimal number. Multiply that answer by 12. Press equal. And you should get 5.01150,311. And it's a non-terminating decimal number. That answer divide by 0.07. And you should get 71.59290164,811. It's a non-terminating decimal number. That answer in your calculator multiply by 8,000 pesos. And you should get 572,743.21 pesos. Hence, the value of the investment of 8,000 pesos to be paid at the end of each month for 5 years will result to a value of ordinary annuity equal to 572,743.21 pesos. We now take another example. For our second example, consider the following problem. XYZ company has committed to a legal settlement that requires payment of 50,000 pesos at the end of each year for the next 10 years. What would it cost XYZ company if it were to instead settle the claim immediately with a single payment, assuming an interest of 5%? In this problem, XYZ company has a legal obligation to pay an amount of 50,000 pesos at the end of each year for 10 years. But XYZ company has opted to make a single payment instead, today, at present, now, with an interest of 5%. That's understood to be compounded annually because the regular payments, each payment amounting to 50,000 pesos to be made at the end of each year, is to be made at the end of each year. So it's understood that 5% is compounded annually. But as I said, the XYZ company has opted to make a single payment now at present time instead of making a regular payments of 50,000 pesos at the end of each year for 10 years. So if that is the decision of XYZ company, the problem asks for what amount should be paid by XYZ company now to settle its legal obligation. So in this problem, the required is the present value of ordinary annuity. And this is a problem of ordinary annuity because the regular payments of 50,000 pesos are to be made at the end of each year for 10 years. And the required amount to be made now, the single payment amount, the single payment or the single amount to be made now to settle the obligations of XYZ company is the present value of all these regular payments of 50,000 pesos to be made at the end of each year for 10 years. So the amount of regular payment is denoted by R is equal to 50,000 pesos. And this amount is to be made annually at the end of each year for 10 years. Therefore, T equals 10 years. And the company wants to pay to make the settlement now with interest of 5% understood to be compounded annually. So 5% is J, in decimal is 0.05, and M is equal to 1. And as I said, the required here is the present value denoted by P of this ordinary annuity. For ordinary annuity, the present value of regular payments made at the end of each period is denoted by P and is given by R times quantity 1 minus quantity 1 plus I to the minus N, divide all over I, where I, small I here is the interest rate per period, by formula I is equal to J divided by M. Where J is the given interest of 5% compounded annually, therefore M is equal to 1, and 0.05 divided by 1 is 0.05. N is the number of regular payments to be made, and by formula N is equal to M multiplied by T. Where M is 1, because the payments are made annually once a year. For 10 years, T is equal to 10. M is 1, T is 10. And we substitute into this formula the value of R, 50,000 pesos, I is 0.05, and N is 10. Again, we compute the value of P using our calculator. And we start again with 1 plus 0.05, that's 1.05. And you raise that to the power negative 10. We have 1.05 1.05 to the power negative 10. And you should get 0.61391,325. It's non-terminating decimal number. And from that answer in your calculator, you subtract that answer from 1. And you should get 0.3860867. Again, it's a non-terminating decimal number. And that answer in your calculator, you divide by 0.05. And you should get 7.7217349291. It's a non-terminating decimal number. And that answer in your calculator multiplied by 50,000 pesos. And you should get 386,086.75 pesos. Thus, instead of the company, XYZ company, paying 50,000 pesos at the end of each year for 10 years, XYZ company can settle its legal obligation by paying today, now at present time, this amount of 386,086.75 pesos. And the legal obligation of XYZ company will be settled. For our third example, consider the following problem. XYZ company is contemplating the acquisition of a machinery asset. The supplier offers a financing bill under which XYZ company has to pay 500 pesos at the end of each month for 36 months, or the company can pay 15,000 pesos in cash right now. The current market interest is 5%, which is the better offer. Now, in this problem, XYZ company would like to acquire or purchase a machinery asset. And the supplier of this machinery asset has given XYZ company two options. The first option is to pay 15,000 pesos in cash right now. And the second option is payment of 500 pesos at the end of each month for 36 months. And 36 months is equal to 3 years. And if 500 pesos is to be made at the end of each month for 3 years, therefore the company has to make a total of 36 payments, monthly payments. And if the company chooses the second option of paying 500 pesos at the end of each month for 36 months, there is a interest based on the current market interest rate of 5%. And this interest rate of 5% is considered to be an annual interest rate. Therefore, we have to calculate the interest rate per month. If the company opts to pay 500 pesos at the end of each month for 36 months, we write the given. For the first option, the company may choose to pay 15,000 pesos in cash right now. The second option is a payment of 500 pesos at the end of each month for 36 months. That means the number of payments to be made for the second option is 36 payments. Each payment equal to 500 pesos. But there is an interest of 5% based on the current market interest rate of 5%. And we have to divide this by 12 to get the interest rate per month. And so M is equal to 12, and the interest rate per month is, by formula, I is J divided by M. 0.05 divided by 12. And to compare the second option with the first option, we have to find the present value of these regular payments of 500 at the end of each month for 36 months. To compare it with the cash payment of 15,000 pesos now. Again, to compare the second option with the first option of 15,000 pesos in cash now, we have to find the value of the second option, the value of the payments of 500 pesos at the end of each month for 36 months at present time or now. So for the second option, we calculate the present value of ordinary annuity that involves 500 pesos payment at the end of each month for 36 months. And the formula is given by the following. The formula to calculate the present value of ordinary annuities denoted by P is given by R times quantity 1 minus quantity 1 plus I to the negative n divided by all over I, where I is the interest rate in this example per month given by formula J divided by N, where J is the current market interest rate per year of 5% in decimal is equal to 0.05, and we want the interest rate per month, so we divide 0.05 by 12. We take M equals 12. And we divide 0.05 by 12. If it's a terminating decimal number, we use decimal number. But if it's a non-terminating decimal number, we leave it as is 0.05 divided by 12, and we substitute 0.05 divided by 12 directly into the formula for present value for ordinary annuity. .05 divided by 12 is a non-terminating decimal number. 0.004166 is repeated without n. So we leave it as is 0.05 divided by 12. And we substitute 0.05 divided by 12 for I into this formula. And the number of payments, 36. Monthly payments are the amount of equal payments, 500 pesos to be paid at the end of each month. Again, to calculate the value of P, we start with 1 plus 0.05 divided by 12 to the power negative 36. And the answer in the calculator, we subtract from 1. And to divide the numerator by 0.05 divided by 12, we multiply the numerator by the reciprocal of 0.05 divided by 12, which is 12 over 0.05. Or you can type this directly into your calculator. You may start with 1 minus quantity 1 plus 0.05 divided by 12 to the power negative 36. We have 1 minus, use the grouping symbols, open parenthesis, one plus 0.05 divided by 12. Close parenthesis. For the numerator, you should get 0.13902375553. It's a non-terminating decimal number. That's the answer in the numerator. And that answer in the numerator in your calculator, you multiply by the reciprocal of the denominator. Reciprocal of 0.05 divided by 12. So the answer in your calculator, multiply by 12 and divide by 0.05. And and you should get 33.36570128837. Again, it's a non-terminating decimal number, but that answer in your calculator, you multiply by 500 pesos. Let me just check the answer. We have 1 minus 1 plus 0.05 divided by 12 to the power negative 36. And you should get 16,682.85 pesos. So the value of the regular payments of 500 pesos at the end of each month for 36 months or for 3 years has a value of 16,000 pesos, 682.85 pesos at present time or now. So we compare this value of the ordinary annuity for the second option with the first option of 15,000 pesos cash now. If XYZ company is trying to save some money, then the better option is to pay 15,000 pesos cash now. And the company will be saving 1,682.85 pesos. If the company is after some savings, the better option is the first option, the payment of 15,000 pesos cash now. And you should write your final answer as the better option is 15,000 pesos cash now. And we choose this option as the better option because XYZ company will save 1,682.85 pesos, which is the difference between 16,682.85 pesos and 15,000 pesos. The company will save an amount of 1,682.85 pesos if the company will pay 15,000 pesos in cash now for payment for the machinery asset it wants to acquire. Our next example, consider the following problem. XYZ company wants to invest 5,000 pesos of its funds in a long-term investment at the beginning of each year for the next 5 years. The company will earn 6% interest compounded annually. What is the value of the payments at the end of the 5-year period? If the interest was compounded monthly and the amount invested were 4,000 pesos, At the beginning of each month, what is the value of investment after 5 years? This problem has two parts, and this problem involves annuity due because the amount, the regular payments, the regular amount of investment are to be paid at the beginning of each period. In the first part of the problem, the amount to be paid at the beginning of each year is 50,000 pesos. And the company will earn an annual interest of 6%, compounded annually. In the second part of the problem, the amount to be paid, the regular amount to be paid at the beginning of each month is 4,000 pesos at the beginning of each month. And it's understood that we use the same interest rate of 6%, but we have to compute the interest rate per month by dividing 6% or 0.06 by 12. We write the given information. In the first part of the problem, the amount of regular payment to be made at the beginning of each year is 50,000 pesos. And the interest earned from this investment of 50,000 pesos every year to be paid at the beginning of each year for 5 years is 6% or 0.06 compounded annually. Therefore, M is 1. Interest is computed once a year. And the payments are to be made over a period of 5 years, so the period of investment is 5 years. And we want to find the value of this investment at the end of the 5-year period. The required is A, accumulated value. In letter B, the payments now are equal to 4,000 pesos to be made at the beginning of each month for 5 years. The same interest rate, 6%, annual interest rate 6%, but now it's compounded monthly because the payments are to be made at the beginning of each month. So we need to find the interest rate per month by dividing the annual interest rate of 6% or 0.06 by 12. Therefore, we take M equals 12. And the period of investment is 5 years. We want to find the value of the investment at the end of the 5-year period. The required is A, the accumulated value of this annuity due, where payments are made at the beginning of each period. And the formula for calculating the accumulated value of annuity due is given by the following formula. For both parts A and B of the problem, we use the same formula. The accumulated value denoted by A of annuity due. It's given by R times quantity 1 plus I to the power n minus 1 all over I multiplied by this factor 1 plus I. where I, for letter A, is the interest rate per year, and it's equal to 0.06. And R is 50,000 pesos. And N is the number of payments. In letter A, the payments of 50,000 pesos are made at the beginning of each year for 5 years. Therefore, the number of payments N is 5. Or by formula, N is equal to M multiplied by T, but M is 1 and T is 5. 1 multiplied by 5 is 5. Therefore, N is equal to 5. And we find this value using our calculator. Again, we start with the sum. 1 plus 0.06, raise that to 5. And from the answer in the calculator, you subtract 1. And the answer in the calculator divide by 0.06. And the answer in the calculator multiply by 1 plus 0.06 or 1.06. And multiply again by 50,000 pesos. We have 1 plus 0.06 is 1.06 to the power 5. And you should get 1.33822557776 from that answer in your calculator. Subtract 1, minus 1. And the answer in your calculator, divide by 0.06. And you have 5.63709. That answer in your calculator multiply by 1.06. And you should get 5.9753185,376. That answer in your calculator multiplied by 50,000 pesos. And you should get 298,765.93 pesos. Hence, the value of the long-term investment, of 5-year investment of 50,000 pesos to be paid at the beginning of each year for 5 years with interest of 6% compounded annually will have a value of 298,765 and 93.93 pesos at the end of the 5-year period. Now we compute the value of the long-term investment if 4,000 pesos are made at the beginning of each month for 5 years with interest, annual interest of 6% but compounded monthly. We now calculate the value of the long-term investment, 5-year investment for second part of the problem. where the regular payments are 4,000 pesos to be paid at the beginning of each month for 5 years. Since the payments are to be made at the beginning of each period, each month, we want the accumulated value of this annuity due with payment of 4,000 pesos at the end of each month. So R is 4,000 pesos and I is the interest rate per month. We have the same annual interest rate of 6%, but now we calculate the interest rate per month. So we divide 0.06 or 6% by 12 because we have 12 months in 1 year. Therefore, I is J divided by M. By formula, the interest rate per period, in this example, the interest rate per month is given by I and is equal to J divided by M, where J is the annual interest rate of 6% or 0.06, and we divide by 12 because we want the interest rate per month. And we have 1 year is equal to 12 months. And 0.06 divided by 12 is a terminating decimal number, 0.005. And let us check. We have 0.06 divided by 12 is 0.005. If you get a non-terminating decimal number, just leave it as is 0.06 divided by 12. But since we have a terminating decimal number, we can use 0.005 for I in this formula. And we find the total number of payments to be made at the beginning of each month for 5 years, and is equal to M multiplied by T. The payments are to be made monthly, and in 1 year we have 12 months multiplied by the number of years or the period of investment, 5 years. 12 by 5 is 60. So we replace in this formula N with 60. And we find the value of A using our calculator. We start with 1 plus 0.005 or 1.005 to the power 60. And as in the calculator, we subtract 1. And the answer we divide by 0.005. And as in the calculator, we multiply by 1.005 and multiply again by 4,000 pesos. We have 1.005 to the power 60. You should get 1.348850152. And that answer in your calculator, from that answer you subtract 1 minus 1. And the answer in your calculator, divide by 0.005. And you have 69.77003050, and that answer in your calculator multiplied by 1.005 and multiply again by 4,000 pesos. And you should get 280,475.52 pesos. Hence, the value of the 5-year investment for the second part of the problem that involves payment of 4,000 pesos at the beginning of each month for 5 years with interest at 6% annual interest. But compounded monthly is 280,475.52 pesos. We consider the last example. XYZ company is paying a third party 100,000 pesos at the beginning of each year for the next 8 years in exchange for a copyright. What would it cost XYZ company if it were to pay the entire amount immediately, assuming an interest rate of 5%? In this problem, XYZ company is like purchasing a copyright with payment of 100,000 pesos to be paid at the beginning of each year for the next 8 years. But XYZ company is thinking of paying all the amount immediately. That means at present time, now, today, instead of paying 100,000 pesos at the beginning of each year for 8 years. XYZ company is considering paying the entire amount now, immediately at present time, but with interest of 5% compounded annually. So in this problem, we want the present value of this annuity due. And this problem involves annuity due because the payment of 100,000 is to be made at the beginning of each year. And we want the present value. If XYZ company wants to pay all the amount in exchange for the copyright, now we want the present value of this annuity due. And we write the given information. The regular payment R is 100,000 pesos. The annual interest rate denoted by J is 5% or 0.05. And this is compounded annually because the payment is to be paid at the beginning of each year. So this annual interest rate is already the interest rate per year. And T is equal to 8. Eight years. The required here is the present value of this annuity due. For annuity due, the formula for computing its present value is given by the following. Present value of annuity due is denoted by P and is given by R times quantity 1 minus quantity 1 plus I to the power minus N all over I multiplied by the factor 1 plus I, where I is the interest rate per period. In this example, I is equal to 5%, or by formula I is J divided by M. By formula, the interest rate per period is equal to the annual interest rate divided by the number of interest conversion periods. In our example, J is 5% compounded annually. We take J as compounded annually because the payments are to be made annually at the beginning of each year. So I is J divided by M. J is 0.05 divided by M is 1. So I is equal to 0.05. And N is equal to the number of payments for the next 8 years. And the payments are to be made at the beginning of each year for 8 years. Therefore, the number of payments is 8, but by formula, N is equal to M multiplied by T, where M is 1 and T is 8. 1 multiplied by 8 is equal to 8. And we substitute R equals 10,000 pesos. I we replace with 0.05 and N we replace with 8. And we find the value of P, the present value of this annuity due using our calculator. Calculate the present value of this annuity due in our example. R is equal to 10,000 pesos. Our small I, the interest rate per year or per period is 0.05. Raised to the power minus N, where N is equal to the number of payments, 8. Again, we can compute this directly in using your calculator. You enter these numbers directly into your calculator and you compute 1 minus quantity, 1 plus 0.05 or 1.05 to the power minus 8. The answer divided by 0.05 and the answer multiplied by 1.05 and multiply again by 10,000 pesos. We compute the present value directly using our calculator. We have 1 minus 1.05 to the power minus 8. And you should get 0.32316063797. It's a non-terminating decimal number. And that answer in your calculator, divide by 0.05. And you should get 6.4632127.59426. Again, it's a non-terminating decimal number, but that answer in your calculator multiply by 1.05. And the answer in the calculator multiply again by 10,000 pesos. And you should get 67,863.73 pesos. The XYZ company has the option of paying the entire amount immediately or now or at present by paying 67,863.73 pesos in exchange for a copyright. Actually, the XYZ company has two options. The first option is to pay an amount of 10,000 pesos at the beginning of each year for 8 years. So that's with interest of 5% annually. Or the second option is to pay the entire amount, make a one-time payment of 67,863.73 pesos. But this is actually the value now of the annuity due that involves payment of 10,000 pesos at the beginning of each year for 8 years with interest at 5% annual interest rate compounded annually. For your practice, please try the following exercises. Number 1, find the value of an investment that pays 6% interest compounded quarterly if payments are made at the letter A, end of each period for 5 years. And letter B, beginning of each period for 5 years. In number 1, each period is equal to 3 months because the given interest rate, the given annual interest rate of 6% is compounded quarterly, which means that interest will be computed 4 times in a year every 3 months. Therefore, one period is equal to 3 months. And in letter A, the payments are made at the beginning of each quarter or at the beginning of every 3 months. And in letter B, the payments are made at the in letter A, the payments are made at the end of every 3 months, while in letter B, the payments are made at the beginning of every 3 months of each quarter. In letter A, the payments are made at the end of each quarter, at the end of each 3 months. In letter B, the payments are made at the beginning of each quarter or the beginning of every 3 months. Number 2, for acquisition of PC, portable computer, which of the two options is better? The first option A, cash payment of 75,000 pesos. Letter B, payment of 1,500 pesos at the end of each month for 4 years with interest at 10%. The annual interest rate of 10% is understood to be compounded monthly. Therefore, for letter B, you have to compute the interest rate per month by dividing 10% or 0.1 by 12. Letter 3, Mr. X is obligated to pay Miss X an amount of 5,000 pesos at the beginning of each month for 3 years for moral damages. If Mr. X wants to settle his legal obligation now, what amount should he pay if 6% interest applies? Again, the interest rate of 6% here is considered to be compounded monthly because the amount of 5,000 pesos is to be paid at the beginning of each month. So you have to compute the interest rate per month by dividing 6% or 0.06 by 12. And lastly, number 4, ABC Company will pay 15,000 pesos at the end of each quarter for 7 years for an equipment bought on installment with interest at 12% compounded quarterly. And so the period here is equal to 3 months. The interest rate, 12%, is compounded quarterly, which means that the interest will be computed 4 times in a year. And in 1 year, you have 12 months. Divide by 4, you have 3 months. So each period in this example is 3 months. And the payment of 15,000 pesos is to be made at the end of each quarter. That means at the end of every 3 months. if ABC company decides to pay the entire amount now, what amount should it pay? And before you proceed with the solution, you determine if the problem involves ordinary annuity or annuity due. In annuity due, payments are made at the beginning of each period. In ordinary annuity, payments are made at the end of each period. And that ends our lesson for today on ordinary annuity and annuity due. If you have question about the lesson today, you ask your question in the comments below. And thank you for joining me in my class today in Mathematics Self-Investment.